Intro music fades in and out. Hey everyone, and welcome back to the channel. If you're a developer, a sysadmin, or anyone who spends a significant amount of time in the command line, you're probably familiar with RipGrep. It's that lightning-fast, Rust-powered search tool that often leaves "grep" in the dust well. Today, we're diving into a story that's been lighting up hacker news. A story that might make you pause and double-check your tooling. A significant bug has been discovered where RipGrep Musl binaries are occasionally segfaulting during very large searches. That's right, a segfault, a segmentation fault. For the uninitiated, that's not just a minor hiccup. It's a crash. Your program tries to access a memory location it shouldn't, and the operating system steps in, saying, "Nope, not on my watch," and shuts it down. This isn't just an inconvenience. It can mean interrupted workflows, lost data, and a serious headache for anyone relying on RipGrep's robustness. So, what exactly is happening here? The reports indicate that this issue specifically affects RipGrep binaries compiled with "Musl libc", especially when dealing with extremely large datasets or complex regular expressions. While RipGrep is renowned for its speed and efficiency, this particular edge case seems to be exposing a vulnerability. The discussions on Hacker News reveal a deep dive into the technicalities, with developers and maintainers trying to pinpoint the exact cause. It's a classic example of how even the most optimized and beloved tools can harbor subtle, complex bugs that only surface under specific, demanding conditions. Now, for those wondering, why "Musl"? What's the difference? It's a great question. Most Linux systems use "glibc", the new C library. "Musl", on the other hand, is an alternative C standard library designed for static linking, smaller binaries, and resource efficiency. It's often favored in embedded systems, containers, and distributions like Alpine Linux, where a smaller footprint and static dependencies are crucial. The benefit is often a self-contained executable that's easier to distribute and has fewer runtime dependencies. The downside, as we're seeing here, is that it can sometimes expose different behaviors or bugs compared to "glibc" builds, especially in how memory is managed or threads are handled. The critical takeaway here is that if you're working in an environment that specifically uses "Musl" builds of RipGrep, perhaps in a Docker container based on Alpine, or a highly optimized embedded system, you might be susceptible to these segfaults. Imagine running a crucial search across terabytes of log files, only for RipGrep to crash halfway through, giving you an incomplete result or no result at all, without clear indication of failure other than the crash itself. This isn't just about losing time. It could lead to missed critical information, security blind spots, or incorrect data analysis. The Hacker News thread is a fascinating read, illustrating the collaborative nature of open-source development. People are sharing reproducible steps, analyzing stack traces, and offering theories ranging from subtle memory allocation issues to complex race conditions within highly optimized code paths. It's a testament to the community's dedication to robust tools. The fact that a tool is widely used and optimized as RipGrep can have such a bug underscores the immense complexity of modern software, especially when dealing with different compiler targets and system libraries. So, what should you do if you're a heavy RipGrep user? First, if you're not using a "Musl" build, you're likely not affected by this specific bug. If you are, or you're unsure, it's worth checking your RipGrep version and how it was compiled. You might consider using a "glibc" build if possible, or at least being aware of this potential instability when performing very large searches. Keep an eye on the official RipGrep GitHub repository and the Hacker News discussion for updates and potential fixes. This isn't a reason to abandon RipGrep. It's a reminder that even the best tools sometimes need a little TLC. And the open source community is actively working to make it even better. It's these kinds of deep dives into critical software issues that really highlight the backbone of our digital world. We rely on these tools daily, and understanding their intricacies, even their flaws, makes us better, more informed developers. What are your thoughts on this RipGrep Segfault? Have you experienced similar issues with other tools? Let me know in the comments below. Don't forget to like this video if you found it informative.